Hi, this is Jeff Spencer, Math 120 instructor for the Community College of Denver, and this is our video lecture over Section 5A. And for our second unit, we're going to be looking at the statistics unit, and we're going to start in Section 5A with the fundamentals of statistics, but the whole next unit that we're covering has to do with statistics and probabilities. This is the beginning of the statistics. So statistics has two definitions. It's the science, the class or the process of the science of collecting, organizing, and interpreting data. And then statistics themselves are the data that describe or summarize something like a mean or a standard deviation or something like that, or a range is a statistic. So some definitions we need to go through. This is going to be a lot of just terms and definitions in this section. The population in a statistical study is the complete set of people, of things, or people or things being studied. So it's the whole group. It's everything or everyone within the group that you're trying to do research on. The population, once again, can be people or it can be things. It can be all the products that you produce on a product line, something like that, or people, like a group of people, residents of Denver, community college students, something like that. The sample is a subset of the population in which the raw data are actually obtained. So usually we want to do research on a population, but we can't conduct a census of everybody in the population. So we sample a subset of that population and collect data from that sample. Population parameters are the characteristics of the population that a statistical study is designed to estimate. So a classic example here is if you're trying to figure out the percentage of folks that are going to vote for a certain candidate. You don't actually know that population parameter. You can't ask everybody before the election day. You don't have the time to do that. So that's the thing that you're trying to figure out about the population. And then to do that, you collect a sample statistic and you figure out the percentage of folks that are going to vote for that candidate from your statistic. And the idea is that that is used to estimate the population parameter. So we're going to identify these things from this example. It says agriculture inspectors for Jefferson County measure the levels of residue from 3 common pesticides on 25 ears of corn from each of the 104 corn producing farms in the country. So solution, the inspectors seek to learn about the population of all ears of corn grown in the country. All right, so population is, so we have a sample of 25 ears of corn. So the population is all ears of corn grown in the country. So in order to do this, to figure out information about all the ears of corn in the United States, they sample 25 ears of corn. So the sample is the number. Every time we have a sample, you'll know the number. All right, so the sample will always be some number of things that you're sampling from the population. In this case, it's 25 ears of corn. And the population parameter that we're trying to figure out, from each ear of corn, we're trying to figure out the level of residue. So the population parameter is the average level of residue from the 3 pesticides on all corn grown in the country. And in order to do that, the statistic that we do, or that we collect, is the average from the 25 ears of corn from the sample. Okay, so here are the basic steps of a statistical study. The goal of your study precisely is kind of what I like to call the research objective. Then we choose a representative sample from the population. We collect the data from that sample and summarize this data by finding sample statistics. We use the sample statistics to infer the population parameters, and then we draw conclusions. So here's a good picture of it. The start is to identify the goals. What do we want to figure out about this population? What are we trying to figure out? Could it be voting statistics or averages or something else? So then once we've decided our goals in our population, we sample from that population. That's a subset of the whole group. Then from that sample, we get data from that sample and summarize it using sample statistics and graphs and things like that. And then we make inferences about the population using various techniques about the population parameters, what we think the actual numbers are based on our statistics. And then we draw conclusions and say, okay, the level of pesticides is good or bad, or something needs to be done because there's too much. Okay, so the big part is when we collect the sample, we want to make sure it's a representative sample. So a representative sample is a sample in which the relevant characteristics of the sample members match those of the population. So we don't, if we want to do a political study, we don't only want to just sample men or men of a certain age. You want to make sure that you get a good cross. Another way of saying this is a good cross section of the population. A statistical study suffers from bias if its design or conduct tends to favor certain results. So if I just ask American men of certain ages, maybe they will have bias on their response. So you want to get a good cross-section, a nice representative sample, so it doesn't suffer from bias. So we have sampling methods, various sampling methods. We have simple random sampling, and that's kind of misleading. They say it's simple. Theoretically, it's simple, but in practice, it's really hard. Every sample has the same size, has an equal chance of being selected. In order to do that, you have to use like a number generator and have everybody in the population have a number next to them, and then you sample everybody based on their number. So usually, in the first place, you need to have everybody in the population with a number, which is hard to do in itself. Then you need to have a computer generator generate random numbers, and then you need to be able to get the data from those random samples from the population. So instead we use some other easier techniques like systematic sampling. We use a simple system to choose the samples, such as selecting every 10th or 50th member of the population. So this, you could like stand outside of a grocery store and ask every 10th person who they're going to vote for or whatever you want to collect about the population. Convenient sampling is not a good method, but it happens sometimes. We choose a sample that is convenient to select, such as people who happen to be in the same classroom or in the same close proximity to us, or Facebook would be a convenient sample. And then the last one is stratified sampling. We use this when we want to see if there's difference among subgroups or strata within a population. So that could be geographically or based on male, female, age groups, things like that. So we identify those subgroups and draw a simple random sample within each subgroup. The total sample consists of all the samples from the individual subgroups. Usually that's done in political research. So here's just a picture of it. The simple random sampling involves, having everybody has a number on the database, and then we use a random number generator to pick our sample. Convenient sampling is just, using close proximity. Systematic is doing, say, like in this picture, every third person, sampling every third person to reduce bias between the responses. And stratified sampling is you put the population into strata. This is like a female, male, and then we randomly select within each strata or group. So here's an example where we're conducting a survey of students in your dormitory. You choose a sample by knocking on the door of every fifth room. Since it's every fifth room, this is a systematic sample. To survey opinions on a proposed new water line, a research firm randomly draws the addresses of 200 homeowners from a public list of all homeowners. That would definitely be the simple random sampling. Simple random sample. Agricultural inspectors for Jefferson County check the levels of residue on 25 ears of corn from each of the 104 corn-producing farms in the country. So each farm is like a subgroup or a stratum, so this is stratified sampling. And this one says, anthropologists determined the average brain size of early Netherlands in Europe by studying schools found at 3 sites in southern Europe. This is somewhat convenient because they just use the only data that they have. Okay, definition of we've already talked about bias, excuse me. All right, so types of statistical study. So we've gone over population, sample, population parameter, sample statistics, and then sampling methods. Then we have the types of statistical study. So an observational study is one, and then we have an experiment. We compare observational study versus experiment. So in observational study, researchers observe or measure characteristics of the sample members, but do not attempt to influence or modify these characteristics. So really the way you can think of this is it's just a survey. We're just surveying people and getting responses without really controlling various variables. We're not making sure that everybody has the same amount of money or that everybody's the same age. In an experiment, researchers apply a treatment to some or all of the sample members and then look to see whether the treatment has any effects. So the big key with an experiment is that people are given a treatment, like a pill or a new technique of exercise or something like that, and we see if it has any effect. So the treatment group in an experiment is the group of sample members who receive the treatment, and then the control group is the group who do not receive the treatment. Sometimes that's the placebo, not all times. It is important for the treatment groups and the control groups to be selected randomly and be alike in all respects except for the treatment. So usually when you have your two groups, you want them to be as similar as possible. Same age, same sex maybe, many other things that you can control, whether they smoke or not. So you want them to be very similar. All right, and then you give one group the treatment and one group some other, not the treatment, or some placebo or something like that. So placebo is, a fake treatment, and so it makes people think that they're getting a drug or a treatment when they're actually not. And it helps us distinguish to see if the treatment is actually working. So the placebo effect refers to a situation in which patients improve simply because they believe they're receiving a useful treatment. So that would help us determine if the treatment itself is effective or not. So in statistical terminology, the practice of keeping people in the dark about who is in the treatment group and who is in the control group is called blinding. Experiment is single blinded. The participants do not know whether they are members of the treatment group or members of the control group, but the experimenters do know. And in a double-blind experiment, neither the experimenters nor the people receiving the treatment or control group know who they're in. So with a medical study, people could get an experimental drug and then a placebo, and they don't know which one they're getting, and neither does the experimenter who gives them the drug. They just say, "Here, take this and see if it improves your symptoms." So a case control study is a different kind. It's a special kind of observational study that it resembles an experiment because the sample naturally divides into two or more groups. The participants who engage in the behavior under study form the cases, and the participants who do not engage in the behavior are called the controls. But they naturally fall into these things. The experimenter does not choose these groups. They just either engage in the behavior or they do not engage in the behavior, and that gives it a case control study. Oops, sorry. So let's see here. Okay, I don't want that example in there. It's too long. Okay, so let's just pick what type of statistical study based on the research objective here. So this one says, what is the average income of stockbrokers? So what could we do? Could we do an observational study and an experiment with blinding or experiment without blinding? So if we wanted to figure out the average income of stockbrokers, the population would be all stockbrokers. I think we could just sample some stockbrokers and get their income, and that would be an observational study, just a survey. We can survey the income of various stockbrokers and get an estimate of the average income of all stockbrokers. Here's another example. Do seatbelts save lives? So it would be unethical to do an experiment in which some people were told to wear seatbelts and others were told not to wear them, because we know that there's certain risk involved with that. So instead we can conduct an observational case control study. Some people choose to wear seatbelts, the cases, and others choose not to wear them, the controls. By comparing death rates and accidents between cases and controls, we can learn whether seatbelts save lives, and they do. So we can look at, at any accidents and were the people wearing seatbelts or not, and then look at the death rates. And it's clear that there's higher death rates for people that do not wear seatbelts versus those people that do. Okay, here's another research objective. Can lifting weights improve runners' times in a 10-kilometer race? You could definitely run an experiment with this. You wouldn't need any blinding because obviously it's hard to have people lift weights without them knowing that they're lifting weights. But you can definitely have a group of runners do a weightlifting program and another group not do the weightlifting program and then compare their times. Can a new herbal remedy reduce the severity of colds? So this is definitely a double-blind experiment in which some participants get the actual remedy while others get a placebo. We need double-blind conditions because the severity of a cold may be affected by mood or other factors that experimenters might inadvertently influence. So you have to be careful. You just want to do this double-blind so that you're not affecting their recovery, whether or not they're getting placebo or not. Last thing we're going to talk about is a confidence interval. The margin of error is used to describe a confidence interval that is likely to contain the true population parameter. So usually when we get a statistic and we want to use it to estimate something, we create a margin of error around it. So a confidence interval is just the statistic minus the margin of error plus the margin of error. So for instance, this is used a lot with polling results. So it says an election poll finds that 52% surveyed voters plan to vote for Smith, and she needs a majority, which is more than 50 to win without a runoff. The margin of error in the poll is 3 percentage points. Will she win? Well, we got to get the actual interval. So the estimate is 52% with a margin of error of 3%. So we subtract 3 and add 3 to it. So we have an interval of 49 to 55. We could be 95% confident the actual percentage of people planning to vote for her is between 49 and 55. Because this confidence interval leaves open the possibility of either a majority or less than a majority, this election is too close to call. Alright, so that's the end of our lecture on this, and we'll see you next time.